This video illustrates how you can solve a simple integral equation using the TI-89 calculator. These kind of integrals often come up in dynamics. So I'm going to have, we're going to integrate ADS equals VdV, and for the acceleration I'm going to assume it's the function s over 100 plus 2. The initial velocity is 8 and the initial position is 1. And I want to find the velocity as a function of position, and I also want to find the velocity at s equals 10. So this will be a function and this will be a number. We set it up the same way for both problems. We put in the acceleration, and the lower limit for s is 1 because that's the initial, and then in one case we'll just leave it a variable s, and in the other case we'll integrate to 10. And then for v it starts out at 8 and goes to some arbitrary v. And we can solve this. So we turn it on here, and we push the F2 to bring up the solve feature, and it's an integral equation, so we push F3, go down to integrate, push enter, and now we've got the integral. And the function we want to integrate, the way it's set up, we integrate a function of s from 1 to s, and the calculator won't let you do that. So we'll have to do a variable change, and I'm going to go ahead and use x. So the integral will be x divided by 100 plus 2. And we're going to integrate that on x, and the lower limit is 1, and the upper limit is s. So I can use the alpha key and go down and find s. So I've set up the first integral here, and then that's equal to, and we'll choose the second integral now, and we're going to integrate v dv from 8 to v. But once again, you can't have v as one of your limits if you want to have v in the integral. It just won't let you do that. So we'll change it to y. So integrate y dy, and the lower limit is 8. And the upper limit is v. So I'll use the alpha key and choose v here. And of course I've got two variables there. I can solve for one in terms of the other, comma, and I'll solve for v and close that. And when it's just one equation, you don't have to use the curly brackets around the variables like you do with multiple equations. When we hit solve, it comes and it solves it. This is a pretty complicated function, but it says that v is equal to 0.1, and then there's a big square root that has a bunch of s's under it. And of course, in order for that to be valid, the square root has to be positive, because you can't take the square root of a negative number, so it tells you that. And then, or you can have a negative value, but still you have the integral, you can't take the square root of a negative number. So you can solve it out and get the functional, get v as a function of s, and you'll have to choose which of those two functions makes sense. The second case is we go in and we want to make the upper limit 10. So I can go to the start of the equation here. Here's s over 100, integrate on x, and there was the upper limit of s. And so I can just change that to 10. And push enter, and now we just get a number. And one case v is minus 10 or v is equal to 10, and we'd have to choose which of those makes sense. Of course, our velocity starts out positive, the acceleration is always positive between, so it's the positive number that makes sense. This gives you an illustration of how to solve the integral equations.